Sun goes around a black hole in the constellation Sagittarius at the center of the Milky Way galaxy.
Scientists have made a jaw-dropping discovery right at the heart of these enigmatic cosmic beasts. They've unearthed something mind-blowing and terrifying inside a black hole, challenging everything we thought we knew about these cosmic wonders. Buckle up, because we're about to unveil the astonishing secrets lurking within a black hole's mysterious core. Are you curious to know more? Let's dive in. Black holes are a fascinating phenomenon. You see, according to a brilliant scientist named Albert Einstein and his theory of general relativity,
the surface gravity is so high that you cannot escape it, even at the speed of light. You are forever trapped.
Gravity is not a force like magnetism or pushing and pulling. Instead, it's a result of how space and time are curved or bent by objects with mass and energy. Imagine you have a massive object, like a star, in space. It has an enormous amount of mass and energy, and this causes a deep dent or curvature in the fabric of space and time around it. This curved space and time is what we call a gravitational field. The more massive and energetic the object is, the stronger its gravitational field and the deeper the dent it creates. Now, keeping that theory in mind, let's talk about black holes. They are some of the most extreme objects in the universe, with unimaginable amounts of mass and energy packed into a tiny space. They have so much mass that their gravitational field becomes incredibly intense. This intense gravity creates a super deep and very strong dent in the fabric of space and time. Here's where things get really crazy. The gravitational pull near a black hole is so incredibly strong that it forms what we call an event horizon.
That the event horizon is not some wall, it's just space moves smoothly through and across the event horizon.
This is like an invisible boundary or point of no return. Once something, like an unlucky spaceship or even light, crosses this boundary, it can never escape the black hole's grasp. It's as if the black hole has an invisible force field that holds everything inside, including light, which is usually the fastest thing in the universe. Just to emphasize how extraordinary this is, imagine you're shining a flashlight. The light beams travel really fast, about 300,000 kilometers per second. But if you were somehow inside a black hole, the speed you would need to escape its clutches would be even faster than the speed of light. That's impossible according to our current understanding of physics. So, any light that enters a black hole becomes trapped forever, unable to break free.
Light into the black hole. Light coming from farther away gets bent around it.
Black holes have a couple of types. We have stellar mass black holes. These are the ones that form from massive stars nearing the end of their stellar journeys. They typically have masses ranging from a few times to several tens of times that of our dependable sun. Stellar mass black holes are actually quite common in our galaxy and other galaxies out there in the vastness of space. Now, let's shift our gaze to the colossal supermassive black holes. These cosmic behemoths are the true giants of the black hole family. They boast masses that are millions or even billions of times greater than that of the sun. Picture them as the masters reigning at the centers of most large galaxies, including our very own Milky Way. These mighty black holes are thought to have formed during the early stages of the universe, born from the collapse of massive clouds of gas and dust, or from the merger of smaller black holes. Their presence greatly influences the evolution of galaxies, shaping the formation of stars and planets that dance around them. Now we come across a rare breed known as intermediate mass black holes. These elusive creatures sit right between the stellar mass and supermassive varieties in terms of mass. They are like the middle children of the black hole family, somewhat mysterious and not commonly spotted. Their origin is still a bit of a puzzle, but scientists speculate that they may have formed from the collapse of incredibly massive stars during the early cosmic eras, or from the union of stellar mass black holes in dense and bustling star clusters. Lastly, we have the intriguing primordial black holes. These are the potential relics from the very beginnings of our universe, born shortly after the Big Bang itself. They emerged from fluctuations in the density of matter and energy during those cosmic early moments. Primordial black holes come in a wide range of sizes, from minuscule ones with masses just a fraction of a gram to massive ones thousands of times heavier than our sun. It's important to note that while they are a captivating idea, primordial black holes remain hypothetical and have yet to be directly observed. Black holes have another interesting aspect: their rotation. For instance, there are the Schwarzschild black holes. These are the simple and straightforward ones they don't spin. Think of them as the calm and steady black holes of the bunch. They are described by the Schwarzschild solution, a mathematical description in Einstein's theory of general relativity. These black holes have a nice spherical event horizon, which is like a boundary that marks the point of no return, and a singular point at the center called the singularity. It's like a singular dot with an immense gravitational pull.
In the same way, if you fall in across the event horizon of a black hole, you are going to the middle, the singularity it's called. So that's your future.
Next, we encounter the Kerr black holes. These ones are all about that spin. Kerr black holes are described by the Kerr solution in general relativity. They have an oblate, or slightly flattened, event horizon, and a singularity that takes the shape of a ring. The rotation of a Kerr black hole creates something called the ergosphere. This region around the black hole is like a cosmic whirlpool, where space and time get dragged along by the spinning black hole. Now let's meet the Kerr-Newman black holes. These are the rock stars of rotation, with a little extra something. They not only spin but also carry an electric charge. Kerr-Newman black holes are described by the Kerr-Newman solution in general relativity. They share many similarities with Kerr black holes, like their oblate event horizon and ring-like singularity. However, the electric charge adds a twist to their story. The event horizon and singularity get a bit distorted by the electric field. And scientists have discovered ultramassive black holes. You see, an ultramassive black hole is a truly extraordinary cosmic heavyweight. It tips the scales at more than a whopping 10 billion times the mass of our trusty sun. We're talking about a black hole that's so massive its gravitational pull is unimaginably strong. Anything that ventures too close to it would be in for a wild ride. Now, how did we even discover these cosmic monsters? As we create better and more advanced telescopes and gadgets, we'll be able to use them to look closer at Gaia BH1. Secondly, Gaia BH1 is a bit of a cosmic oddball. Most of the black holes we know about have these supermassive companion stars that feed them gas. This creates a whole bunch of bright X-ray emissions, making the black holes much easier to spot. It's like those stars are throwing a massive cosmic spotlight on the black holes. But Gaia BH1 is different. It doesn't have a supermassive star partner, meaning it's not creating those bright X-rays. This makes it a quiet black hole, just minding its own business in the dark corners of the galaxy. These quiet black holes are notoriously hard to spot, making Gaia BH1 a rare and exciting find. Thirdly, Gaia BH1's discovery suggests that our galaxy might be chock full of these quiet, elusive black holes. Until now, they've been really good at escaping our notice. Our astronomers have done some number crunching, and their estimate is truly exceptional. They believe there could be hundreds of millions of black holes in our galaxy. But guess how many we've actually confirmed so far? Just a few dozen. But Gaia BH1 has taught us that black holes can be different. Some might have low mass or faint companion stars that don't produce much light or radiation. They might be more common than we think, but spotting them is a whole different ballgame. We'll need more sensitive and precise measurements to reveal their presence, and that's an exciting challenge for future astronomy. And you know, the story of Gaia BH1 isn't just about the discovery of a nearby black hole. We also have a magnificent piece of space technology known as the Gaia Space Telescope. This high-tech marvel was launched into the cosmic beyond by the European Space Agency back in 2013. Now, Gaia is not just any old telescope. Its mission? To craft a three-dimensional map of our galaxy. It does this by measuring the positions, distances, motions, and properties of over 1 billion stars. Yeah, that's right, 1 billion. This brings us to another exciting revelation. Gaia BH1 is not an only child. In 2023, the Space Telescope played a vital role in discovering another black hole, aptly named Gaia BH2. This one's a bit smaller than BH1, and it's orbiting a giant star roughly 3,800 light-years away. Just like its older sibling, Gaia BH2 was found by observing its gravitational influence on its companion star. The star's motion and spectrum, again, gave away the hidden black hole's presence. So there you have it. Gaia BH1 is not just a black hole. It's a clue, a signal, a hint at what lies hidden in the vast expanses of our galaxy. Its discovery has shed light on how much we still don't know about the universe, and how much there still is to discover.